record. Share my screen. Okay, so can you guys see my screen now? Hello? Is my screen visible to your desktop or laptop now?
Yes, sir.
Okay. So I haven't checked your midterm exam yet, so I'll just give you guys an update maybe next week or 2 weeks from now, since I also haven't checked your activities yet. Your lab number 0 up to lab number 4. Up to lab number 2 only, because this is your work for today, lab number 3 and 4. Anyway, before that, of course, we have to discuss the module 4 or the assembly language 4 first. So this is actually a continuation of our previous topic, the assembly language 3, the assembly language instruction times 86 microprocessor. So this is the part B, wherein we're going to discuss now the basic arithmetic instruction. So all in all, this will teach you on how to, do some addition, subtraction, multiplication, and then division. And then a little bit of a jump, okay, function. Jump, and then a conditional jump, and one short example, I think. Yeah, one example of a compare. Okay, so all in all, we have a total of like 3 topics or 4. Anyway, this will be just a quick discussion, since this module is quite easy to understand. So in here, we're going to talk about addition and subtraction first, or add and sub for the MU886 or the times 86 assembly language. So here is the syntax for the addition. So add, and your first operand, and then your second operand. Okay, just follow that one. If you want to subtract, then just change the add into SUB or sub. Okay, so in here, the second operand is added to or subtracted from the first. So same criteria, whatever you guys have learned in our previous modules, it's always from right going to left. So this operand 2 will be added to your operand 1, or this operand 2 will be subtracted to your operand 1. Okay, so I hope we're clear with that one. So we just have some guidelines here. So operands must be on the same type. So both should be bytes or both should be words. Okay, if other type, then it should be also the same, so other than bytes or words. And then first operand may be a register or data item memory location. So if you don't know what is a register or data item, so you can go back to our previous modules. So with that, you will learn about register data or data item or memory location. And then second operand may be a register, data item, or a memory location, or immediate. So the only additional thing is the immediate. So it could be a decimal already, or a hexadecimal character already. Like for example, this is an immediate. This is an immediate. This is an immediate. So immediate character. So it is not in the form of a register or any kind of variable. So it's a straight value. Okay, that's what we mean by immediate. And then 2 data items as first and second operand not allowed. So one should be, introduced first, and then the other one can be a data item already. So 2 data items as first or second operand is not allowed. Okay. So we have this example right here, a very simple example. So again, the that model small, that stock 100 each, that data that code up to this point is the default syntax already. So you can just copy that one as it is. And then here's now the the new thing when it comes to addition or subtraction. So we have to declare a variable, move DL, and then it has a value 4, and then we're going to add a value of 2 on that DL. So just add DL and then 2. So we have here your first operand, and then this is your second operand, and then this is your operator. So we're adding 2 to that previous line or that DL. So of course, as a result, of course, 4 plus 2 is equals to 6. Are we clear regarding with this one? Hello? Are you guys able to follow? Okay, again, first operand, this is our operator, which we're going to add, and then this is our operand. So in here, we have another, let's say, function wherein we want to add, okay, another value on that previous value of DL. So just put this one, add DL, and then 48. So from 6 plus 48 will give us a value of 54. However, if you guys are going to ASCII, na lang, para mabilis. Is do take note that the one that it will display is the character, okay, not the decimal computation or the integer computation. Where is that one that I'm always using? Let's try this one. Is it clear? Maybe we can use ASCII. We can use the converter. Hexadecimal. Why is it here? It's T. See, this one is quite blurry. Let's try to find a clearer copy. This one is not complete though. 48, 49, 54. It doesn't have a label. We need the one that has a label. This one. Okay. So this is the decimal computation. So 6 plus 48 is 54. But the one that it will display is the character, which is equals to 6. So let's not use that one. So let's try to redo this one. And we'll see what is the result of this example. Okay. So let me know if ever I mistype a word or a letter. I can correct it right away before running our program. So move EH is just an interrupt to display the character. Display the result, and then force CH to end our program. That code will be exit data. Okay. So in here, as you guys can see, it gives us the result of 6. Okay. So not 54. Okay, because it always displays the character. Okay. So are we clear so far up to this point or up to this line? Well, actually, that's already it. We've already finished the entire program. So were you guys able to follow with this given example?
Yes, sir.
So let me know if ever you guys have a question or concern or clarification, okay? So in here, this is for the add and subtraction. Okay, let's try subtraction because we don't have an example for subtraction, okay? So instead of add, we'll make this one subtract. So 4 minus 2 is 2, and then we'll add, or let's deduct another one. So 4 minus 2 is 2, and then minus 1 again is 1. So in ASCII code, 1 is, well, it's actually a start of heading. So this is not a displayable character. So maybe we can come up with the result of maybe 46. So I don't know what this one is, but it seems that this is an asterisk. 46. Let's try 46. So how are we going to come up with 46? 50 minus 2 minus 2. That is not a asterisk, but this is a dot. I'm not really sure if it's really dot. But yeah, it seems that it is really a dot. What about 45? So that is negative, I think, or minus sign. 45, it's exact another 3. So 2 minus 2 is 48, and then minus 3 is 45. So yeah, we'll display the negative sign or the subtraction sign. Okay, so yeah, that's how simple it is to, do a addition or subtraction in assembly language. All right, so let's proceed to the next one. So we can also add, via increment or via decrement. So increment will add 1, and then decrement will decrement, of course, or will reduce or will subtract 1. So let's redo this example. So everything is the same except for this one. Move BL4, add BL2, and then add BL48. So while I'm doing this one, you can also do this one on your own, terminal. So you can also verify if it's really correct or no. And add BL48. And then we're going to increment or add another 1 or plus 1. Then we'll display, and then from here, and decrement, and then display again the results for each. Okay. So there is just a note right here that outputs would be on the same line. So this is the first output. Where's that one? This one, it will display 55, which is equal to 7, and then it decremented by 1. So 54 is equal to 6, I guess. Okay. So I'm not really sure if you guys can see this one, but you can, open a new tab and then check what is the value of 54 in character in ASCII code. Okay. So let's try this one out. Oops, why is it 3? Okay, let's see. 4 plus 2 is 6, plus 48 is 54, plus 1 is 55. And 55, 7. But why is it showing 32 for 3 and 2? BL, sub BL. So let's verify everything. Yeah, still 32. Move BL. This one should be add, not subtract. Okay, so we wasn't able to change that one. There you go. So we now have here 7 and then 6. So 7 for the 55 and then 6 for the 53. So were you guys able to follow this one?
Yes, sir.
All right. So let's proceed now to multiplication. So in here we have mule and I-mule. Okay, mule for the unsigned numbers, and then I-mule for the signed numbers. But in most cases, we'll only be using mule since we only have, or in most cases, we only use unsigned numbers. Okay, except if you're going to use signed numbers, then you can use I-mule. Just change that mule or just add I before the mule or I-mule. Okay, so here is the syntax: so mule and then the operand, and then I-mule for the assigned number and then operand. So for byte operand, processor assumes that it will be multiplied by the value of EL. And then for the word operand, processor assumes that it will be multiplied by the value of AX. Okay, so as you guys can see, it follows this format. So byte is multiplied to AL, and then word will be multiplied to AX. Okay, so just follow that syntax, okay, because that is where it stores the multiply or the product, okay, of this result, this multiplication. So it's always use AL or EX. So we have this example right here. So move AL, so we have an initial value of 2, and then move BL is equal to 3 or 3, and then multiply BL. So again, this one is always assuming that the second operand will be multiplied to AL. So mul BL, so it already knows that 3 will be multiplied to our AL. So 3 times 2 is of course 6. And then we have another operator here, which is add. So 6 plus 48 is equal to 54. So 54 is what? 6. So 54 is equal to 6. That is what we are expecting here. So let's try this one out in our own assembly emulator. So we have here move BL into BL, and then this one is move BL followed by 3. So 2 times 3, and then this one is multiply BL, BL 48, move BL. So in here, whatever is the value of your DL, okay, so it will be displayed in our EL, okay, or it will be stored in our EL. So we have to get the value of EL, and then we'll store that one in EL, okay, and then will be displayed by this line. So let's try. Oops, why is it different from what we are expecting? Did we miss something? Move EL. This one should be 2 and then 3. 48, 3 first each. Okay, let's try this one more time. Why is it still different? Did we miss something? Move each first each. Move each, each. Move BL. It's decrementing right here. And we have 2 display. We should only have 1. Move BLAL. See. I think everything is same now. Oh, why is it so different? What is wrong? Move EL, move BL, multiply BL, add BL 48, move BL, move each here to each, in 21 each, move each percentage, in 21 each. Why is it different? 55. Move each, in 21 each. Does anyone knows what is wrong with our code? That code a bit smaller. And then end. Let's try to open a new one. Still give us the same result. Can you guys try this one on your own terminal?
So yung sa
There.
may add DL po, palitan nyo na lang ng add DL.
Ah, let's do that one. Thank you, Mr. Martinez. So there you go. We now have a result of 6. Hindi ako nagbabasa ng chat ha. Meron pala kayong mga chat. Okay, anyway, so thank you so much, Mr. Martinez, for noticing that one that instead of BL should be AL. Okay, so we now have here a value of 6. So yeah, that is it for the multiplication. So are we clear with this one so far?
Yes, sir.
All right. So let us proceed now to division. So this one is similar with the multiplication. So div for the unsigned numbers and then IDiv for the signed numbers. So in here, this one generates two results. So as we already know, so if we divide, could be, it could have a quotient and then a remainder, or a quotient only. But in most cases, of course, we don't know. Okay, so it could be a quotient and then a remainder. So the quotient will be stored in our EL, and then the remainder will be stored in our EH. So operand given is a divisor, while the divided is always assumed to be EX. So I know this one is quite confusing. So let's have an example. So this one is a single digit operands and output. So everything is pretty much the same up to this point. So here are the new things or the new codes. So move EL is equal to 6. This is the, let's say, the first number. Operand 1, and then move BL is the divisor or the second number. Okay, so as you guys can already see here, we have 6 divided by 3. So we are already expecting that this 1 will divide the first number. And then move AH is a let's say 0. Okay, so this one should be always a 0. Okay, so we have to clear the AH. So clear AH, since div instructions takes AX as divided. So recall that AX is 16-bit, is compressed of EH, which is the EH and then EL, which are both is 8-bit. So there's a need to clear the EH. Okay, and then we have here now the div BL. So all in all, we have 4 lines of codes in properly executing a division for this one. So 6 divided by 3, followed by this move AH 0 and then div BL. So the rest could be, if you want to add more, if you want to subtract more, if you want to increment, decrement. So it is completely up to you. But in here, we already have a result of 2. Okay, and then you just need to add 48 because 2 in here is undisplayable. That is the start of text. So we want to see a display or a character. So plus 48. So that is 3. Yeah, that is 3, right? 2 plus 48 is 50. So 50 is equal to 2. Okay, that is the character that will be displayed on this given example. So let's try this one out. Move EL is 6, move BL is 3. And then here is the new one. We have to clear your AH or your EL and then EX. And then from mule to become division or div. Again, everything now is the same, I guess. So there you go. We now have the result of 2. So just note that all inputs and outputs and examples and activities must be single digits or 1 byte only. Other instructions for multiple digits will be discussed later in this course. So for now, we'll have these examples, these basic examples. If you guys will be needing 2 inputs, or let's say more than 2 input, okay, and then more than 2 output, then this will be discussed, or that will be discussed later on. Okay. So for now, are we clear with this given example? So it gave us a result of 2 or a character of 2. Hello, are you guys still around?
Yes, sir.
Yes, sir.
So were you guys able to follow, or you guys need maybe a minute or 2 more minutes to have a read and we try to understand? All right, so I will wait. So just give me thumbs up once you are very good with this example. Okay, so thank you, Mr. Martinez. What about the others? All right, so it is now only Mr. Alburo and Mr. Bukat. Okay, good. What about Mr. Bukat? Okay, so maybe he is not here. Anyway, so let us proceed now to the sequence instruction. So this one will let you control the flow of your code or your program. So description of the order in which instructions in the program are executed. So this one involves the transfer of control to the address of an instruction that does not immediately follow the one currently executing. So we have two possible ways to do this one. Could be forward or backwards. Forwards, of course, execute a new series of steps. And then backward, of course, it's for straightforward. It will go back to the same step. Okay. So we have an example right here. Let's say jump L1, then it will skip some lines. So no matter how many lines it is. But I think this one has a limitation though. So jump is like maybe 10 lines of codes. It can skip that 10 lines of codes. But if it's longer than one, if it's longer than 10, let's say 10 or 15, I'm not really sure how many lines. So you could use LGMP. So LGMP stands for long jump. Okay. So this one is just a shorter range. If you want jump a larger or a longer range, then you have to use LGMP or long jump. Okay, and that is for the forward, and we have here the backward. So we can go below. We can also go back at the top. So jump L1, then we'll go back to this label right here. Okay, so label in the code segment. So this is a markings within a code segment to control the execution of a program. So similar with variable, okay, it will go to that specific variable, or it will go to that specific line of code or function code. Okay, so label name, any valid name so that you can think of. So type could be far or near. So we have here the syntax. So this is the label name, and then the label, and then the type. Okay, so these are the inputs that you can change. Label name and then the type. And then here are the guidelines for naming labels. So it can be up to 31 characters. So that is the maximum characters that we can use in putting a name of a label. So use short names for a group of related labels in all the same area of the program, and use longer or descriptive names for isolated labels. But all in all, this one is still up to you. It could be short, could be long, or whatever you want. Okay, that is your own variable, your own label. And of course, this apply the programming meaning rules. The basics can start with a character. It's any character as long as it's the alphabet. Okay, so you cannot start with a number first. And we have here now the example for jump instruction. So it is an instruction that tells the processor to continue execution at the address given by a particular label. So we have here jump L40. So it wants to jump to this variable or to this label L40. So we have a total of 3 labels. So this is the first one wherein maybe it has 5 lines of codes. And then this is the second one, maybe this one has, let's say, 3 or 4 lines of codes. And this is now the L40. So as you guys can see, it will skip those lines and then it will proceed right away to our L40. Simple as that. Okay, this one is similar with the if condition. Okay, wherein if it's true, then we'll go right here, right here. So wherever you want to go your execution line of code. Okay, so in here, just use jump to execute that one or to do that one. Okay, so are we clear so far for this jump L40?
Yes, sir. Clear naman po.
So this is for the forward. If you want to do the backward, then just put that one below and then many lines of codes, and of course it it can go back at the other time or wherever line of code that you want to go back. So we have here the conditional jump instructions. Let me just check if we still have enough time. So I think we don't have enough time anymore, so we now only have maybe 10 seconds. So we'll just continue this one in part. So goodbye for now and see you guys later. So I will end this one now and then just wait for a new link, okay, for the part 2.